Hey guys, welcome to my channel Study with me. What? Wait, I hope you are not well today. But no worries, it will be alright after watching this video. Before starting the video, please make sure you like and subscribe channel. Wait, one more thing. Do not forget to press the bell icon. Okay, let's get into the video. Today we'll be discussing about complex integration. Okay, it's complex integration actually yeah, how we can say this is calculus of complex function. So we come to know about what is an algebraic function and trigonometric function, and yeah, we know algebraic function and trigonometric function, etc. functions. But what is a complex function? How it is represented? So it is represented as f of z, which means u plus I w. So this is a format of a complex function. This is a format of a complex function. Okay. So in this video today we'll discuss about few important topics which are important for GATE as well as your SEM exams, and those topics are, we go with first thing, when you hear the word complex function you realize that the main important concept, the basic level concept is just finding out analytic functions, and the next thing is to find out whether a function is harmonic or not. Okay, so we can say it as harmonic function. Okay, the next thing is transformation. In that transformation we have so many, but the important thing is bilinear transformation. Okay, bilinear transformations. And now the main part, this is all about the complex functions. These are the main important topics of complex functions. Now I will write the topics which are important for calculus of a complex function. Okay, now we go with Cauchy's theorem, and the main thing I forgot in complex integration is CR equations. So what is CR? Cauchy's Riemann equation. Okay, and now any complex integration, we have Cauchy's theorem and we have Cauchy's integral formula, Cauchy's integral formula, and residue theorem. So these are 6 topics so that you can cover nearly 2 marks in the GATE exam, 2 marks in GATE, as well as 28 marks. Okay, 28 marks in your SEM exam. Okay, so this is the highly weighted topic. Now let's get started. So I'll give a brief introduction of this, and we'll go with some problems. So part 1 of this video will be the brief introduction of what is a complex function, what is an analytic function, what is a harmonic function, what is a bilinear transformation, what is a Cauchy's theorem, Cauchy's integral formula, residues theorem, and what are the CR equations. And second part of of this video will be the solving of problems. Okay, so there is a one question: would you need to do questions for GATE separately? The answer is definitely no. Okay, because as a complex in this topic, complex integration is very tough topic. You can get all of the problems from your SEM exams itself. That means if you follow book B.S. Grewal, If you follow this entirely book, you can easily score in this exam, okay? So now we'll get started with what is an analytic function. Okay, so what it is, if the differentiation of a complex function, that is, if the differentiation of f of z or is unique, that is, the derivative of f of z is unique for point z in a region R, then the function is said to be analytic function. Once again, the derivative of the complex function f of z is unique at a point z in a region R. Okay, so this is about analytic function, and now comes with CR equations. So you can write that dou u by dou x equals to dou v by dou y, and dou u by dou y equals to minus dou v by dou x. So these are the CR equations in coordinate form. So actually you have in a polar form, but that's not very important, okay? So we won't be discussing this polar form. So if you want, yeah, definitely we can try. Dou u by dou x equals to 1 by dou theta, sorry. No. It is x. Okay, dou u by dou x equals to 1 by r dou v by dou theta. And the second one, dou u by dou y equals to minus 1 by r dou v by dou theta, dou u by dou theta. Okay, so these are the polar forms, and now we'll be discussing about what is an harmonic function. So harmonic function. Okay, so what is an harmonic function? If a function is f of z is analytic, if a function f of z is analytic, and dou square v by dou x square plus dou square v by dou y square is equals to 0, then the complex function f of z is said to be harmonic function. So this is about harmonic function, and now we go with bilinear transformation. Bilinear transformation. So generally in mathematics you don't have a vast things to be explained. You should go on with the flow of formulas, like, okay. So now what is bilinear transformation? That is, if for u there's a point given w and a z, so what is a bilinear transformation? You should change the point given this with respect to, like, in the form of w equals to 1 by z, etc., like this form, w equals to some z forms, f of z. Okay, you should change into these forms. That is known as bilinear transformations. So I'll give you how to change that, okay. And if 3 points are given in a w and 3 points are given as z, then w minus 1 2 3 3 2 1, remember this one, okay. So you need to follow w minus w1 into w2 minus w3 by w minus w3 into w2 minus w1. So 1 2 3 in the numerator, 3 2 1 in the denominator, just as you write the area of triangle, that is half x1 y1, like that. So like this is the case of writing bilinear transformation, and this is equals to the same way, 1 2 3 3 2 1 for z also, z minus z1 into z2 minus z3 by z minus z3 into z2 minus z1. So you simplify this. What you should do is you simplify these two by cross multiplication, and you should take w terms at one side and z terms at the other side. You should take the w as a common of this and equals to some z function, then w equals to z minus this function. Okay, so this is about your bilinear transformation. Now we go with it. What is Cauchy's theorem? Cauchy's theorem. So Cauchy's theorem is nothing else. If f of z is an analytic function, if f of z is an analytic function, okay, and f dash of z is continuous. F of z is an analytic function. The derivative of f of z is continuous along the closed curve C. Closed curve C. Then we can say that closed integral of f of z dz is equals to 0. Okay, so this is Cauchy's theorem. Now we go on with the Cauchy's integral formula. Cauchy's integral formula. Cauchy's integral formula. Okay. So this Cauchy's integral formula says that if f of z is an analytic function, so the common thing is to satisfy every theorem in your calculus integration, I mean complex integration, the general thing is if your f of z, that is your complex function, should be definitely analytic. To function to be analytic, it should definitely follow the CR equations rule. If this this f of z follows this CR equations, then we can blindly say that this function is analytic. And if this function is analytic, it can satisfy any function, any formula in any theorem in your calculus integration. Sorry, complex integration. Okay, so what is this Cauchy's integral formula? Is if f of z is an analytic function and at a region R, and in this region if a is some point, then we can write that f of a equals to 1 by 2 pi I into closed integral of f of z dz by z minus a. So this is Cauchy's integral formula, and now we go with the last and final and the very important. See, your weightage comes from Cauchy's theorem, okay, Cauchy's theorem, Cauchy's integral formula, and now this one is fucking bastard. This is residue theorem, the very easiest theorem, but time taken. Okay, so this is residue theorem. What this residue theorem says that if a function f of z is an analytic, right, and z1, z2, z3, so on up to zn are singularities of your analytic function, and R1, R2, R3, Rn are residues. Okay, residues. Then we can say that residue of f of a 2 pi I into residue of f of, and that is R1 plus R2 plus R3 so on up to Rn is equals to integral of f of z by z minus a dz plus f of, that is z minus z1, f of z by z minus z2 dz plus so on up to f of z by z minus z and dz. Okay, So how to find these residues r1 r2 rn? How to find these? So nothing but residue of f of a equals to limit z tends to a, z minus a into f of z. That is, if you want in the form of some other else, so we can take that. Let's take r1 as a residue. So residue of f of z1 is equals to the limit z minus z1, z tends to z1, sorry, so z minus z1 into f of z. So this will be in this form. So if a function is given and its denominator is f of z by z minus some 2 whole square, a power is given. If a power is given, in Cauchy's integral theorem, we take its partial fractions. But in this case, we take a formula. So that is a residue of f of a equals, so let's this take it as n 1 by n minus 1 factorial into d power 2 minus 1 by dz power 2 minus 1, that's n minus 1, okay, into z minus a whole power n into f of z, okay. So this is the residue theorem.